Hey guys, welcome to question FM186 of the Further Maths Fortify study guide. This question reads, Mr. Nightcat steals a giant diamond and sells it on the black market for $782,000. Mr. Nightcat takes his $782,000 and invests in a perpetuity that earns interest at a rate of 4.9% per annum. Interest is calculated and paid monthly. Question A then asks, what monthly payment will Mr. Nightcat receive from his investment? So, in order to answer this question, we take our investment amount. Now remember that the interest earned in a perpetuity account is equal to the payment that's made out of it. So we're going to take our initial investment amount at $782,000. Our yearly interest rate is 4.9%, but of course we're looking for the monthly interest rate because payments are calculated and paid monthly. So we're going to divide that by 12 before putting it over 100. Plugging this into your calculator should give you an answer of $3,193 and rounded to 17 cents. So that's the monthly payment that Mr. Nightcat will receive from that investment. We're now given another piece of information which is a little confusing. We've changed the context since our early prototype book from being an annuity to a savings account. So keep that in mind as we move through this. So later, Mr. Nightcat converts his perpetuity to a savings account. This savings account earns interest at a rate of 4.7% per annum, compounding monthly. For the first 3 years, Mr. Nightcat makes further payments of $800 into his savings account each month. The monthly payment is made immediately after the interest is added. After 3 years of these regular monthly payments, Mr. Nightcat increases his monthly payment amount. This new monthly payment gives Mr. Nightcat a balance of $1,150,000 in his savings account after a further 3 years. What is the value of Mr. Nightcat's new monthly payment? Round your answer to the nearest cent. Now we're given two different sets of investment conditions, so we're going to be using two different sets of finance solver calculations. So what we're going to do is figure out how much money he has in his account after the first 3 years, and then figure out what the payments would have to be to get it to that final 1.15 million after a further 3 years. So let's break this down for a second. In the first 3 years, the number of payment periods that are going to pass will be 3 times 12, 36. And the interest rate is 4.7%. The present value will be negative 782,000 because we've got 782,000 that's being invested into the savings account, so it's leaving. He's not gaining that 782, he's storing it with someone else. Payments, now he's making extra additions to his account, so once again, making payments, money is leaving him, minus 800. Future value is what we will be calculating for. Payments per year and compounds per year, 12. It's monthly. Chucking this all into Finance Solver and solving should give you a future value of $931,030 and a rounded 66 cents. Now, what I recommend doing with the next 3 years is copying this amount. So Control-C will allow you to copy the value that's from the future value here and allow you to move it over later when we need it in our second lot of finance calculations. So what we've done here is figured out that after 3 years of Mr. Nightcat invested $782,000 at an interest rate of 4.7%, and each month he's making extra additions of $800, he will have $931,000 in his account at the end of that. Now, for the next 3 years, we know that once again, the number of payment periods that are going to pass will be 36. The interest rate will be 4.7%. Hoping this marker doesn't die on me, 4.7%. The present value we're going to paste over from last time, so that's now going to be a negative $931,030.66. Well, that rounded 66 cents. The payments, this is what we're solving for this time. Our future value will be a positive $1,150,000. And once again, 12 payments per year and 12 compounds per year. Chucking all of this into Finance Solver should produce a rounded value for payments of $2,029.90. $2,029.09. So the new payment amount would be $2,029, or the payment amount for the final 3 years will be $2,029.09. If you have any questions about these two questions, guys, drop them in the comments below. Otherwise, I'll see you in the next video.